Hello everyone, my name is Christina. In this video, I'll be talking about the chemistry behind the clear care contact lens solution with its platinum disc. A little bit of spoiler, this is going to be a demonstration of the decomposition of hydrogen peroxide catalyzed by platinum. This is the materials and procedures involved in this experiment. It will be explained in the following video. For materials, we have a platinum disc, which is attached to this entire device that can be connected to the lens case. So this is the platinum disc. It's a metal, so that as soon as the disc makes contact with the hydrogen peroxide solution that will be stored in this bottle, the reaction begins. And as mentioned, we'll be using the lens cleaning solution, which is mainly composed of 3% hydrogen peroxide stored in this bottle. Lastly, we have this lens case, which is a plastic cylindrical container where the reaction will be taking place. The procedures of this experiment includes first filling the plastic container with hydrogen peroxide solution up to this fill line. So I'll be filling this. And now we can do our qualitative observation. So this is the hydrogen peroxide solution. It is a colorless liquid. And for the platinum disc, we can see that it's a silvery gray, lustrous solid. And now I will immerse the platinum disc in the hydrogen peroxide solution. As you can see, bubbles are formed readily as the reaction takes place, indicating the formation of a gas. The solution also becomes noticeably warm as the reaction proceeds, which is an indication of the reaction being exothermic.
Hours later.
This is the after observation. As can be observed, this solution is a colorless liquid, and the platinum metal or platinum disc remains silver gray and lustrous. Here I've sorted all the observations in a table. Here's my analysis of the chemical reaction. Let's first take a look at the structure of the hydrogen peroxide molecule. It contains a single bond between the two oxygen atoms present, and this bond is very unstable. So what the molecule wants to do is to become more stable. Therefore, it decomposes into two more stable components, water and oxygen. Here's the balanced chemical equation. Two molecules of aqueous hydrogen peroxide decomposes into two molecules of water, H2O, and one oxygen gas molecule with the presence of the platinum solid. However, platinum is not a reactant of this reaction, and the reason is that it was never consumed during the reaction. So if we weigh the platinum disc before and after the reaction, the mass will be the same. So in fact, it plays the role of a catalyst. What does a catalyst do? It increases the rate of a reaction without being consumed. How it performs its task in speeding up the reaction is by lowering the activation energy of the reaction, which is the minimum amount of energy that must be provided to compounds to result in a chemical reaction. The diagram on the right demonstrates how this works. The curve with a higher peak illustrates the natural decomposition of hydrogen peroxide. The one with the smaller peak is the reaction with the presence of a catalyst. The blue arrow indicates how much activation energy is required for the natural decomposition, and the pink arrow indicates that for the catalyzed reaction. The noticeable difference between the energies is resulted by the new introduction of the catalyst. In conclusion, the platinum disc is not a reactant of this reaction. Rather, it is a catalyst which speeds up the decomposition of hydrogen peroxide, which is the only reactant in this demonstration. How this reaction contributes to the disinfection and cleansing of the contact lenses is that the hydrogen peroxide is able to break down any proteins that coat the surface of the lens after usage. The bubbling oxygen gas that's produced also mechanically removes large debris that cling on to the lens. The liquid component of the product, being water, makes it safe to use.